So we have done 2A and 2B. Now we need to move on to 2C. Okay, the 2C says the maximum height of the ball above the ground. Now, the maximum height of the ball, you can get it there. That's where the maximum height is. Okay, and this is a quadratic function. Okay, so your knowledge of the quadratic graph that you learned last year is very important for you to answer this question. Okay, it is very important for you to answer the question. All right, now for this question, there are different approaches in terms of how you can get the height. Okay, there are different approaches in terms of how you can get that height. So in my case, what I'm gonna do is, because we have got a height versus time function there, I can just find the first derivative. Okay, because at the turning point of that function in terms of its graph, the velocity there is going to be equal to 0. So I want to find what is the time here, the time there. Maybe I can call that one t1. I want to find what is the time when the object gets to its maximum height. Okay, so for me to be able to do that, I need to find the first derivative, equate it to 0, and then solve for t. Once I do that, the value of t that I will get, I need to substitute it into the original quadratic function. Okay, so I'm going to do that now, but I have to go to the next page. So I'm going to use this first derivative, that's minus 10 plus 25. So our first derivative is equal to minus 10t plus 25. Okay? Now, since at the maximum height, the velocity is 0. Okay? The velocity is 0 at the maximum height, because that's where the turning point is, and that's where the gradient is 0 from our previous knowledge. So it will be minus 10t plus 25 equal to 0. That's minus 10t equal to minus 25. So t is going to be 2.5 seconds. Okay? So when the ball has traveled for 2.5 seconds, it's going to reach its maximum height. Okay? It's going to reach its maximum height. Now, if you look at the answer we got in the previous question, okay, if you look at the answer we got in the first part of the question, okay, the answer we got in the first part of the question, which is this one here, that one, right? That height was reached at t equal to 2 seconds. Now, that gives us a clue that our maximum height is going to be more than 34 meters, because this height is reached at 2 seconds. Okay? I'm just telling you that because it can guide you in terms of your answer. Okay? Now, we now need to substitute into the original function. So h of t is equal to minus 5t squared plus 25t plus 4. Now this becomes h of 2,5. H of 2,5 will equal to minus 5 times 2,5 squared plus 25 times 2,5 plus 4. Okay, can someone calculate that for us quickly? Need someone to calculate that for us quickly. Okay, so it means our h, or our height at the turning point, or at the maximum turning point, is going to be equal to 35.25 meters. Okay, that's the maximum height of the ball above the ground. Then D says the time taken to reach a downwards velocity of 5 meters per second. Okay, the time taken to reach a downward velocity of of 5 meters per second. Now, for you to be able to do that question, we have to use the first derivative because velocity is the gradient of this function. Okay, velocity is the gradient of the function. So we need to know at what time does the ball reach a velocity of 5 meters per second as it goes downwards. So we are going to have C. Okay, remember the first derivative is actually minus h prime of t equal to minus 10 plus 25. Okay? Now, if you look at it carefully, right, if you do your analysis very carefully, remember velocity is a vector quantity. Okay? Remember velocity is a vector quantity. Now, if you look at part B, okay, part B, this velocity was when the object was going up, it was positive. Okay? When it was going up, the velocity was positive. Okay? When it gets to its maximum turning point, the velocity becomes 0. Okay, because of deceleration caused by gravity. So the object was actually decelerating until you get to a point where the velocity becomes 0, which is at the maximum turning point. And then it starts going down. Which means for this function, we have to substitute here a value of velocity which is negative, because the object is now going down because the fact that initially when it was going up, the velocity was positive. Now it's going down, it's not going to be negative. So we substitute minus 5 because the question says the time taken to reach a downwards velocity of 5 meters per second. So that should be minus 5 equals minus 10t plus 25. And this will give you it will give you 10t equal to 30. So t is going to be 30 seconds. Okay? T is going to be 30 seconds. So when it gets to, remember it is going down now. Okay, it's going down. So it will take about 30 seconds for that object to get to a downward velocity of 5 meters.
So it's not 30 seconds, it's 3 seconds.
Oh, sorry. Thank you. Sorry, thank you. Sorry, thank you for that. It's a silly mistake. Anyway, so that's it. So it takes about 3 seconds for you to get to a downward velocity of 5 meters per second. All right. Okay. Any question then? 5t cubed minus 65t squared plus 200t plus 100. Okay, so where there is t, you substitute 0 there. Okay, so this becomes s0 is equal to 5 times 0 cubed minus 65 times 0 squared plus 200 times 0 plus 100. Okay, so the height initially is going to be, okay, that is 0. And I just need someone to calculate that quickly. Just calculate that for me quickly. Okay, so that gives you 100 meters. Then 3.2 says calculate the car's rate of change of height above sea level with respect to time. 4 minutes after starting the journey on the mountainous pass. Alright? Now it is very important for you here to be aware of this. Okay? We want the rate with respect to time. Okay? 4 minutes after starting the journey. Now, for this question, we just need to find the first derivative. And then where there is t, we'll put what? 4. Okay? So that will be 3.2 So that first derivative will be s prime of t is equal to 50 t squared minus 130 t plus 200. Okay? That's the first derivative. So we need to determine the rate at which the height is going to change. So we say s prime of 4 is going to be 15 times 4 squared minus 130 times 4 plus 200. What answer do you get?
Minus 80, so
So that will be minus 80 meters, okay, that is per minute, right? Per minute. Okay, please don't be surprised that we have a minus there. Remember, if you are dealing with calculus of motion, if there's a minus there, it means we are now dealing with displacement. Okay, it means we are now dealing with displacement. Of course, the question talks about height, but because of that negative, it can be displacement, or if we explain it in terms of height, it means the height is decreasing, which means because the person was traveling on a mountainous path, it means probably the person is going down, so the height is actually decreasing. It is decreasing at a height of 80 meters, so of 8 meters per minute. Okay, then 3.3. Now, 3.3 is an open question. Okay, 3.3 is it's an open question. It says interpret your answer to question 3.2. Okay, now it will depend on your understanding of what that minus means, but I've already told you that if we explain it in terms of the height, it means that the height is decreasing, which means the car is going down. Okay, the car is going down because of a decrease in height, which means you can explain it in whichever way you may want, but you need to know that because of that minus 8 meters per minute, the car is going down. Okay, which means the height itself of that mountainous space is actually decreasing. Okay, so you can decide how you want to interpret it, but you have to make sure that you explain in terms of a decrease in the height above sea level. The height above sea level is decreasing. Okay, therefore the car is what? Is moving downwards. Okay, so I think that's all I can say. You can decide how you can explain it. All right, then 3.4. Okay, 3.4 says, how many minutes after the journey has started will the rate of change of height with respect to time be a minimum? Okay, we want the rate of change of time for it to be a minimum. Now, we discussed this type of a question yesterday after Luandile had asked about the question from that 2016 November paper. Okay? The same concept that we used yesterday, that's the same concept that we're supposed to use there. Because we are dealing with a minimum. So if you interpret the first derivative, you are dealing with the turning point of the first derivative. We need to know what's happening at that turning point. If you decide to use the second derivative, it means that you equate it to 0 and then you solve. So in my case, I'm going to use the second derivative. I'll find a second derivative, equate it to 0, solve for t. Okay? What are we trying to find? Remember, when I taught the graph, I explained to you the relationship between the cubic graph, the quadratic, and the second derivative, which is the linear function. So at the turning point, at the turning point of the quadratic function, the point of inflection of the cubic, and the x-intercept of the linear function, the value of x there is the same. So in this case here, the value of t for all of them, that is the cubic function, the quadratic, and the linear, are the same based on our knowledge of the graphs. So we are going to apply that. Okay, now in this question they ask for a minimum. All the basic idea is just finding the second derivative. Remember, the second derivative is the derivative of the first derivative. So it's also a rate of change. Okay. So the second derivative is going to be, let me go to the next page, it's going to be 30t minus 130. Okay. So 3.4, it will be S double prime of t is going to be 30t, it's going to be 30t minus 130. 30t minus 130. So you get 30t equal to 130. Then you divide there, you get t equal to that 30 by 4 gives us 120. So that should give us 4,3 recurring. So I can just write this 433 seconds. Okay, so that's it then. Now, this is not the only way of doing the problem, right? Now, let's just say for interest's sake, we can use the first derivative, all right? Now, as an exercise, because we can also do an exercise here. Right, let's carry on. All right, so whichever method you decide to use for a question like that, if you see the way the rate of, it's actually a rate of change of a rate. Now you have to use either the first derivative or the second one, depending on the context of the question. But the basic concept is connect your knowledge of the cubic graph, its first derivative, and its second derivative. Okay, remember, I discussed that very, very thoroughly. So by now, I expect all of you to be familiar. Even for your test that you're going to write on Saturday, please don't forget that. There is a relationship between the graphs of the cubic graph, the derivative, and in case I'm talking about the first derivative and the second derivative, together with the questions on application of calculus. There's a relationship. So never think that the graphs are not important. They are important when you're doing questions on optimization. In actual fact, I believe that if you understood the graphs, and you connect them with questions on optimization, you are likely to get most of the answers correct because there is a very strong relationship. Okay, so I think I'll stop there. I need to move on to the next question.